All right, go ahead.
Hey, welcome everybody. Thank you for having me. It's a pleasure. I would like to talk about Podman, the powerful container multi-tool today. So I will speak around about 50 minutes and do some short demos, and then we will have some time to do some Q&A session afterwards. We'll around about 5 minutes. But before we start with the actual content, I would like to introduce myself. So I'm Sasha. Hi. You can find me under that name on GitHub, Keybase, or Twitter. And yeah, I'm mostly contributing to Kubernetes or container runtimes these days. So if you want, then you can drop me also a mail. So feel free to reach me out any time. So I'm happy to get into the discussions with you. So what is Podman? Yeah, Podman is a container management tool. So now we could ask ourselves, what is a container management tool? It's really hard to describe tools or the purpose of their tools these days because container management tools are so huge and there are so many on the, out there. But let's defer that question a bit. So initially, Podman was planned as a debugging tool for the Kubernetes container runtime CRI-O. But now it's more or less a feature-rich tool which can be used as a drop-in replacement for Docker. So this means in the end that mostly every talk regarding to Podman starts with something like, yeah, just put your alias Docker equals Podman and then you're all set. That's not completely true, and from my point of view, we have to go back from that common opinion. Podman behaves a little bit different and also has architectural decisions made which are completely different from Docker. So if we want to get started with Podman, we usually just have to install the packages. So we have packages for Arch Linux, we have packages for Fedora, and also for OpenSUSE distributions. And we also have packages for Mac OS, RHEL, Ubuntu, Raspbian, and it's also already built in OpenSUSE Cubic and Fedora CoreOS as well. During the installation of Podman, we see that there are a lot of dependencies, so that are not only build time dependencies or dependencies which depend on the runtime itself. We also have dependencies which are configuration based. For example, CNI, and also CNI plugins, conmon, and run C down here gives us an indicator that Podman is more or less based on different other tools, or is from a container runtime perspective on a level where other tools around gets used. So that brings us to the architectural effects. So Podman is a daemonless container engine. It uses conmon for container lifetime monitoring. So we will come back to that later. And it supports rootless containers as well. I know that Docker also supports rootless containers these days, but this is more or less an architectural decision made by Podman. It uses the container networking interface, which is it's a standalone project, mostly used in Kubernetes environments for networking purposes. And it also utilizes lower-level container runtimes like runC, or it can also use Kata containers. I think there is a talk today about this topic as well. So then, let's come to the demo. You're pretty good on time. So I wrote a little application, which is called FOSDEM 20, which surprise. And what we can see, this should be readable as well. I baked in multiple demos regarding Podman. So the only requirement to run this demo application is to have a Podman installation, which supports rootless and root-based Podman executions or containers. So then let's start with the first demo, which is about the basics. So running a container in Podman is more or less a trivial task. So we can run a container in Podman like we already would expect it in Docker. So we just run podman run, we create our Alpine container, and we do some echo hello world. And this works, which surprise, pretty nice. We also have a lot of other command line parameters which are already well known from Docker, like you can give containers a name, or you can detach them to send them into the background. And if you do that with that container, which just sleeps forever, then we get a unique container ID back, which can be used to re-identify our container. Oh, we also have a name for sure. If you now run podman ps, then we can see that the container is up and running since some seconds. And we can also exec into that container as well. So if we list the processes inside that container, then we can see that our process with PID 1 is our sleep command, and the PS command has PID 9 in that case. So there's no daemon running for Podman. So this means that Conmon is the monitoring tool which has to be dispatched to actually ensure the lifetime of the container. So if we now look on my local machine and grep for Conmon, then we can see a lot of command line parameters for sure. But we can also see that, for example, it uses runc as runtime, as lower level container runtime, and it uses, for example, the storage driver overlay, so something like this. So these are all information Conmon needs to actually set up the container and track the container lifetime. So this means we can also use runc to have a look into that container as well. So if we do a runc list and then look for our containers, then we see that we have our container up and running. So the container manager is libpod in that case, and I'm the owner of the container. Yay. So this works as well. And if we now kill our process, with signal sig kill, just the sleep process on the local host, then this succeeds as well, and we can see that the container is not running anymore. It has exited on signal 137 some seconds ago. This means that Conmon ensures that the signal gets delivered. It does not ensure that the signal gets delivered, but it ensures that the status of the container gets written to disk accordingly. So let's come to our next demo. We are pretty good in time regarding the isolation principles and Podman. So in Podman, we have the possibility to play around with the isolation between the container and the host. So this means if we now run a container where we specify that the PID is the host and look at the processes inside that container, then we can see that we have access to the processes on the host. So this means we can also run another container which has a name first in our demo, and then we are able to join that container's PID namespace by specifying -/PID container :first, and then we just run another sleeping container in the back. And if we now look into our running containers, then both are up and running. And if we exit into the first container and list at the processes, then we can see that they share the same PID namespace, and both sleep commands are attached to more or less the same PID namespace. So they are running in equal containers, but have the same PID namespace. So Podman is also able to give us more information about the namespaces by specifying Podman PS --NS. And here we can see that they actually share the PID namespace, so this is the same file descriptor. And we, for example, for the networking namespace, they are different. So they have dedicated networking interfaces attached. So let's come to our next demo, which is regarding pods. So pods is a concept coming from Kubernetes. So where multiple containers share a set of common resources like their networking interface. Podman wouldn't be Podman if it would not support pods as well. So let's create a pod. We call it my pod, and it's the same like running a container. We just get a unique identifier back where we can re-identify our pod. And if we now do something like podman pod ps, then we can see that our pod is up and running. So our pod has only one container attached, which is more or less the infra container. So this infra container is the same like this pause container you maybe know from Kubernetes. It just ensures that the pod is up and running and the network interface, for example, is attached to that pod. If we now run a new container, then we are able to specify our pod via --pod. So if we do the same with our sleep example, like we did in previous demos, then we can actually run that container, and then we can also create another container inside that pod. So we are totally free to do anything we want with that pod. And now, if we try to access that Nginx server we currently started, then we will see that we can create a new container, which just a wget on localhost, and we can see that the Nginx is reachable. So this is because pods share their networking namespace. Now we come to a really fancy feature of Podman. Podman gives us the possibility to generate cube manifests from our pods. So we can do this by Podman generate cube, and then we specify our file mypod. And if we look into that file, then we can see that this is a fully working Kubernetes pod manifest with all our containers running in it. For example, we have our wget command here. We executed some commands ago. And if we now remove all our containers from Podman, because this is how the demo should work, then we can demonstrate that we are also able to replay this manifest inside Podman. So this is pretty handy if we want to. So now no container is running, and then we are able to run podman play cube and choose this pod YAML. And if we do this, then we can see that Podman creates a pod, and Podman creates also 3 new containers. And this is more or less everything we did in the previous demo steps. Funny enough, this wget does no fail. This is because this Nginx is not up and running during the execution of this wget, because they are all executed in parallel. This is something which has to be considered when creating pod manifests as well. So it's pretty good. You can also, if you develop a Kubernetes application, then you theoretically could edit this manifest and then try it out in Podman, which is pretty nice, without having the need for Kubernetes at all. So then let's come, we just have 5 minutes left, right? Okay, we are almost done. I think we have a lot of more demos. I hadn't the chance to display all of them. So we have a security-related demo, networking regarding the mounting container storage to the local path, regarding images, regarding systemd handling. So there's a huge feature set of Podman, which is I'm not able to show you all of them. But you can have a look at them on GitHub under my name and then FOSDEM20, or the slides are available at the same domain, but slides.com, FOSDEM20. And I think we can now have a little short discussion if you want, or answering questions. Any questions so far? There. Do you need a microphone? I can hear you, but it would.
The stream won't hear you, so. I saw there was support for macOS. I was wondering how it's implemented on macOS. Does it use the Docker desktop VM? Or?
It's more about the remote client. So Podman has this Warlink API where you have a remote, where you can use a remote client to connect to a Podman instance, and that is all about right now.
Okay, cool.
Other questions? Oh, okay. Obviously, other corner of the room. Who was it?
Can you talk a little bit more about networking and how to forward ports outside of the pods?
Oh, the port forwarding works. How does it work from a technical perspective? So networking itself works via CNI. So you can specify different configurations via the usual CNI plugins. For example, you can specify networks and routes, for example. And rootless networking works via slope for NetNS, which is a user space networking implementation based on a tab interface, which gets mounted into the container. So this is a huge topic. But the port forwarding works, and from my point of view, via Socket, which works the same way in Kubernetes. But
okay,
yeah.
That's great. Thank you.
Okay, I think we are done.
Can we run Podman with a rootless user, and what are the limitations?
Sorry, I didn't.
Can we run Podman with a rootless user?
Yeah.
And what are the limitations?
What the implementation is?
The limitation.
The limitation. Yes. For example, AppArmor doesn't work rootless. So some features don't work rootless, but generally, I would say, because Podman runs in the user namespace, then I don't see any limitation. Now, networking doesn't work via CNI, for example. Could be a limitation, But generally, it works pretty well. The file system works via Fuse Overlay FS, which is pretty feature complete from my perspective. But if you find anything, you have to you have to report it. Yeah.
Okay, thank you.
Okay. And,
So you said that Podman is daemonless and it uses ContainerMon to monitor running containers. If I let a container run in the background, how will it know that the container died so it can be restarted or something of the sort? How does ContainerMon work in that situation?
Yeah, that's totally the job of Conmon to keep track of that. Yeah, Podman just interacts with Conmon.
But does it send like a callback or?
Sorry?
Does it send like a callback to Podman so it knows that it needs to restart the container?
Yes, kinda.
Okay.
But you don't have Podman running, right? So
Yeah.
for example, if you run Cryo, then you have a direct connection between Cryo and the Conmon processes these days,
Okay.
just for tracking purposes. But for Podman, there's nothing running than Conmon when a
Okay, so
container
it's
is
just
running.
a CLI.
Yeah.
Basically.
Yeah.
Okay.
And,
Nice.
and laying out the state on disk.
Yeah. Thank
Yeah.
you.
Is there any support for Windows?
Oh, that's a good question. Yeah, maybe for the remote client, we could build it for Windows. Yeah, but not right now. I don't think so. Sorry.
any other question? Okay, that looks like it.
Thank you.
Thank you.